Sometimes we'll be called on to convert between different kinds of ratios. Sometimes we'll be given a ratio of part to part, but really be interested in a ratio of part to whole, or vice versa. So, for example, we might be told that a basket of fruit contains only apples and bananas, and that the simplified ratio of apples to bananas is 2 to 3. We might then be asked, what fraction of the fruits in the basket are bananas? Which is another way of asking, what is the ratio of bananas to all fruit? Now notice, this problem does not tell us how many fruits there are in the basket. It just tells us a relationship between the number of apples and the number of bananas. But we can imagine the basket as containing this pattern repeated. We have a group of 2 apples and 3 bananas. I've drawn my bananas in orange because the yellow didn't show up very well. I've also drawn my bananas very poorly. But trust me, those are bananas. We have a group of 2 apples and 3 bananas, and we might have several copies of that group, but always 3 bananas for every 2 apples. So in each of these groups, we have 5 fruit. In other words, every time we have one of these groups that contains 3 bananas, we have 5 fruit. In other words, the 2 plus 3, 2 apples plus 3 bananas. 3 out of every 5 fruit are bananas. What's the big idea? We add together the parts to get the whole. Let's see another example. Suppose that at a certain company, 2/3 of the employees are men and the rest are women. Suppose we want to figure out what is the ratio of men to women at the company. That 2/3 of the employees are men means every time we have a group of 3 employees, we have 2 of them are men. And then the remaining one is a woman. So we see that at this company, the ratio of men to women is 2 to 1, which we could write as 2 over 1. Notice that you may not find it necessary to draw the picture. But if you find the picture helpful, definitely draw it.